boys and girls, we got a special treat for you today. I've gotten the opportunity to meet with Mr. Elon Musk, and today we're going to talk a little bit about his aspirations. We luckily got a tour through the program here at Brownsville, and I just see it says Boca Chia, a gateway to Mars. So it's kind of really exciting. I was really happy that I got the chance to see the product that's being manufactured here, these rockets. It's spectacular the way they're doing it, and it's totally different than anything I've seen with rocket production at any other company. So with that, I'd like to introduce Mr. Musk, and I guess maybe you could answer a few questions, or actually I'd rather hear from you than talk. I've been doing a lot of talking lately, and I've had criticisms in the past of you know how you...
Were you talking too much in the interview or something?
Yeah, no, it wasn't in an interview. It was when I did my reports, and and it was what it was.
Okay.
And even on the Model 3 we have, I wanted to show you the gaps on one side, but not on the other. I don't understand how that can happen.
Sure.
So, but
no, I thought your criticisms were accurate. Yeah.
Well, and so I've got a question. We've been traveling all over the place, and suddenly we've got a sticker on the side of the car that says Monroe Live, and people are coming up and showing us their car and telling us about their experiences with a Tesla and whatnot.
Yeah.
These guys are really deep into loving this thing. And it doesn't matter whether it's that 8-year-old or 6-year-old kid that came up, hey, mister, are you Sandy Monroe? People know, and they're deeply involved in the Tesla. And yet, for some reason or other, we have a couple of little problems with our car, and then I see another car, and it's a perfect build. If I would have had that, any kind of comment or response or whatever from that would be greatly appreciated.
Yeah, well, it took us a while to kind of iron out the production process, especially during a production ramp. That's like people, like friends kind of like ask me, like, when should they buy a Tesla? I'm like, well, either buy it right at the beginning or when the production reaches steady state. But during that like production ramp, it's super hard to, be like in vertical climb mode and get everything right on the little details. It's just a super difficult thing. So if you really want like things to be dialed, it's like actually the very early cars, or once production is leveled off, that's when it's going to be best.
Well, we noticed that we have a 21, a Model 3 21, and ours had the little problems. But at the end of the day, this guy's car was fabulous. Paint job was spectacular.
Sure.
But the paint was a big deal.
Sure.
But now, this other car I saw, and it was a Model 3 with white interior, which I personally think is the better color than we got black. But that thing was absolutely pristine, perfect.
Yeah.
That's as good as anybody could possibly do. I just don't understand it. Mine was built this month. His was a month later. Mine had problems. His is perfect.
Yeah, we actually did improve gap and paint quality quite a bit towards the end of last year. Even in the course of December, there was like, we were able to really focus on it and improve it a great deal. Like one of the things that was happening when we were like ramping production was the paint wasn't necessarily drying enough. So it's like, well, if you go faster, it's like you just discover these things. Like, so if we knew them in advance, we'd fix them in advance. But like you ramp the line, and then the paint that had an extra sort of minute to dry, or 2 minutes or whatever. Now it doesn't have the 2 minutes, and so it was more prone to have issues that needed to be corrected. This is like one example.
Yeah.
I mean, production is hell. The real thing that's, I think, unique for cars, for Tesla, is achieving volume production. It was like of any American startup car company, I think Tesla's like the first to achieve volume production in 100 years, basically. Like I think Chrysler was the last one.
Yeah.
So like prototypes, and I've said this publicly, like prototypes are relatively speaking easy, and they're also like fun. Like prototypes are easy and fun, and then reaching volume production with a reliable product at an affordable price is is like excruciatingly difficult.
Yeah.
So
Well, you've done a good job. I mean, I've seen the difference between the one we had in 2018, then the Model Y, that's the first, I never recommended anybody else's, but the Model Y, when we tore that down, people were coming up, hey, which one should I buy? And I said, I'm not into doing that, but if I'm going to buy an electric car, and we've seen everybody's, I mean, we've torn everybody's electric car apart. If I was going to tell somebody to buy one and he had to have one, I would suggest the Model Y. And lots of people did that. This one, this Model 3 we've got, this may be the second one that I'm going to suggest. You know, you can either have one of these two, and then I won't have to worry about you coming back and telling me there's something wrong with my skull or something. That they both work really well.
Yeah.
And I have to tell you, we've gone about almost 6,000 whatever, I can't remember, 6,000 plus miles so far in a couple of days, in a few days. And the seats in your car are phenomenal. Yeah. Absolutely phenomenal. I can't say enough about them. I drive a Jeep Wrangler. Yeah. And if I had to sit in that seat for an hour, I'd have to get a chiropractor sure. and probably surgery. These seats, we were sitting in them for hours and hours and hours and hours, and there's no fatigue. They're brilliant, and you make them yourself.
Yeah, absolutely. So, I mean, what we're really trying to do there with the seat is, and we put a lot of effort into this, is minimize any peaks and any pressure peaks. So it like evens out the pressure. Like if your butt hurts, it's basically going to be because there's some part of the seat that is producing a pressure peak. Yeah. And that's going to just cut off your circulation and make your butt hurt. But there've been quite a few iterations. In fact, I mean, the early Model S's had, I think, probably the worst seat of any car I've ever sat in. Wow. I mean, I called it the stone toadstool. It's like if you wanted to sit on a stone toadstool, that was the early Model S seats. Now, if you sat on it for it's better than a stone toadstool, because if you sat on it long enough, eventually your butt would win eventually. Because your butt can repair itself and the seat cannot. So eventually it would be like acceptably comfortable, but it would be a very difficult wear-in process. And so it's like we try to go from stone toadstool to something that is just I don't know, lap of luxury. It just feels great, you know. That you can sit in for a long time, and it's still comfortable. That was a long journey and a lot of effort.
Yeah, well, it paid off. Like I said, we do a lot of work on different things, and I would say without a question of a doubt, the seats. I never read. We had no room in the back seats, but. We had it filled up with junk, but I would suggest that seat is, in my estimation, for my body and one is the best seat on the planet. There's nothing better than that. And a lot of the OEMs, they don't want to make seats because they say that's something that should be outsourced. And I believe that anything you touch, anything that you're going to interface with has to be made in-house, because that's your profound knowledge. So.
Yeah, absolutely. And you iterate on it and keep making it better. And this particular seat, it has improved quite a lot from the early production Model 3 early production Model 3 to present day. It's improved a fair bit. And like one of the breakthroughs was like actually Franz von Holzhausen had a seat that the studio had done. And I sat in that seat and I was like, wow, this seat's great. And we're like, okay, let's figure out how do we get a production seat to feel like a bespoke, handmade, hand-tailored seat without costing a ton of money. So you just can't, it's very difficult to do that if you're working with a supplier, you know. So.
Well, near impossible, because they got to get it cranked out and moving and quickly. And then what they want to do is they want to take the underpinnings, those weldments or castings, if they haven't gone that far, they want to use those over and over and over again for everybody. And so consequently, everybody may look different on the outside, but inside, probably not so much. So that's good stuff. But I have to tell you about the best stuff. And okay, so we had the beta autopilot system, and and we did have problems. But the problems weren't with your system. They were with the roads. People are painting, either they don't paint in certain areas, or they paint right in the center. So how are we going to get legislation to make it so that things are consistent between states? In the old days, it probably didn't make much difference, but now we're moving into self-driving, and
well, I mean, frankly, I think for self-driving, even if the road is painted completely wrong, and a UFO lands in the middle of the road, the car still cannot crash and still needs to do the right thing. So, what really matters, like the prime directive for the autopilot system is don't crash. Like that really overrides everything. So no matter what the lines say or how the road is done, the thing that needs to happen is minimizing the probability of impact while getting you to your destination conveniently and comfortably. But the prime directive, absolute priority is minimize probability of injury to yourself or to anyone on the road, on the pedestrians or anything like that. So, and it's really, it can't be dependent on the road markings being correct or anything like that. It's just got to be, no matter what, it's not going to crash.
well, I still think that that the road commission's in one I better shape up, because, like I said, Corey and I had an issue, and luckily I got out of it. But what happened was they painted all kinds of lines all over the place. There was an old off-ramp and a new off-ramp and a bunch of cones and some flashing red lights. It was totally, I have no idea. If I had to take that thing and knew I had to take it, I would be totally confused as to what to do where. But when the car came into it, the lines are telling it, okay, go here. And that scared the living daylights out of me. If we would have crashed, if it would have been somebody, I used to race, and I kind of like can get out of stuff, and even though I'm old, I'm kind of agile. But if we would have crashed, the press would have instantly said it was all your fault. And in essence, the fault lies in this massive mess that we were trying to keep up with. And then, quite frankly, I stopped driving in the right-hand lane. That was it. I mean, the car wants you to keep going back there because it wants you to follow the rules. But
no, you can change that. It's a setting.
Oh, really?
Yeah.
You'll have to show us that, because I don't like that one. But it's
Yeah, you just change
following
the setting.
it's following the rules, and that's great. But you have to have the roads at the same thing. So I want to make sure that we've got this on tape, or on whatever, not tape, but video, because I'm guaranteeing you somebody is going to screw up somewhere, and people have to know it's the road that can bugger the things up, as well as whether your autopilot thing.
I mean, it would certainly be helpful to have roads with accurate markings and everything. But like I said, really for self-driving, it's got to be, even if somebody tries to trick the car, they do not succeed in tricking the car.
Right.
Because people will do weird things. So it's got to be maintain safety no matter what, and don't let yourself get tricked. That's so.
Well, maybe that's the best segue ever, because what I want to do is I wanted to talk about. I actually John. What's John's last name?
John McElroy.
No, the guy that gave us a ride.
Head of the Silicon.
Yeah. Okay, well, I'll just say
Silicon.
John.
LA Silicon Valley.
Yeah, LA Silicon Valley, whatever. I thought. Anyways, he gave us a ride, okay, and we taped it, and you can hear me going, my voice went up about 3 octaves. I was so excited. Corey said he's got a sore ear from me giggling or whatever. I've sat in F-18s. I didn't fly them, but I was sat in them, and I saw how everything was supposed to work on the ground.
Yeah.
I flew, or through a simulator, I flew a C-17. I know what you can do and what you can't do, what autopilot will do, and I never seen anything, never, ever seen anything quite like what you've got in the new self-driving thing. This is just absolutely brilliant. This should get into the marketplace as fast as possible. It's accurate. It's much more accurate than what we have in the Model 3. It's accurate. It's kind of aggressive, because if there's a hole, it'll find that hole. It makes left-hand turns, which I've heard from everybody can't be done. I mean, these are the things that this will save more lives than airbags, seat belts, and anything else that anybody's ever gotten. Because
that's correct. It will. Yeah.
I was so impressed. I couldn't believe it. And I have some videotape, and I just asked you for using it. I want to put that out. I want the rest of the world to know what the new standard is, because in the auto world, some people are going to win, some people are going to lose, and some are just going to fade away. The more they fade away, the worse it's going to be for the general population. But I'm telling you, that system, I don't know who you developed or how it developed, but that is absolutely
it was developed
stunning.
internally. Like we developed the hardware and the software. We've got a very talented team that we built from scratch at Tesla for autopilot software and autopilot hardware. We've got a really lot of talented people.
I got to ask a technical question. How many lines of code is in that thing? A bazillion? A trillion? What?
Well, I don't think lines of code is necessarily a metric of goodness.
Well, maybe, but I mean, it's so intuitive. Either that, or it's AI and it's cognitive knowledge or something. I don't know, but
yeah, I think generally I would consider lines of code to be like a large number of lines of code to be bad, not good. And in fact, I would generally give like 2 points for deleting a line of code, 1 point for adding a line of code. And then the lines of code thing, when you have neural nets, where you've
right, I got it.
It's not, there's a whole lot of statistics going on, basically a lot of dot products going on. The lines of code becomes especially not a figure of merit for when you've got a lot of complex neural nets operating. You have a lot of matrix math. I mean, that said, I think we haven't actually counted it, but I mean, it's maybe, I don't know, a few 100,000 lines of code or something like that.
Really? A few 100,000? That's amazing.
I would like it to be less,
Well, your philosophy about getting rid of lines of code, I have a philosophy about getting rid of parts.
Sure.
And the more parts you get rid of. In fact, a long time ago, when I counted up the number of things in the wheel area, I said this should all be one part, and then
Totally agree.
yeah, and you got it. Actually,
I can tell you how that problem arose, and it was like first of all, I think you can generally see the errors, the organizational structure errors. They manifest themselves in the product. So for the sort of wheelhouse areas of the body, there was a lot of engineering done, and there were a lot of right answers to the wrong question. So somebody would say, like, well, what's the best material to make this little section of the body out of? And what's the right material to make this little section? And I think we've got probably the best material science team in the world at Tesla, and then actually a lot of them also do work at SpaceX as well.
yeah, I know. I'm coming to that question too. Or yeah.
Yeah, but the engineers would ask, what's the best material for this purpose, best material for that? And they got like 50 different answers. And they were all true individually, but they were not true collectively.
Right.
And when you try to join all these dissimilar dissimilar alloys, and you have galvanic corrosion, so you've got to have better seal, and you've got gaps that you've got to seal, and you've got to join these things, and some of them don't. Some of them need to be joined with rivets. Some of them need to be joined with spot welds. Some of them need to be joined with resin or resin and spot welds. And it looks, frankly, it looks like a sort of bit of a Frankenstein situation when you look at it all together. And it's I can't emphasize enough the nightmare of sealing in between the gaps. That is like that might be the most painful job in the whole factory is spackling on the sealant. Yeah. And then you have a little. If there's like a little error with curing the sealant, or like just somebody who's been working for several hours makes a slight mistake, then you've got now you've got an MBH issue because you've got a little hole, and you've got a leak issue, and it's just like this is terrible. So, I mean, you can muscle through it, and we have, but it's just way better to have a single piece casting. And then you don't have any gaps, no sealant. You don't have dissimilar metals. And you can reduce the size of the body shop dramatically.
Right.
So just having the the rear body castings for Model Y allowed us to reduce the body shop by 30%.
Yeah.
So there's roughly 1,000 robots on the Model 3 body line, which, by the way, is also not a figure of merit. You want fewer things, not more.
Yeah.
We got rid of 300 robots just with that rear body casting.
Yeah.
And then when we go to the front body casting, we'll get rid of another 300 robots.
Right. So I don't know if you, well, you probably don't have time for my stuff, but I have in my shop for 15 years a rear casting, a center casting, and a front casting to make a car.
Yeah, I totally agree.
Thousands of engineers, and I mean big time executives, and
Sure.
walk by it. Hey, have you ever thought of doing? Well, you know, Sandy, and they don't do it, and they don't do it because we've got this body shop.
Sure.
And because they've continuously hung their hat on this thing, they figured, you know, this is the way it should go. But when you came up, I will tell you, I'm very disappointed. I thought I was going to see a single piece casting in a Model 3 as well. I thought you were going to shoot the two and then glue it together, but that's all right.
I mean, at some point we will
I'm getting over
probably switch to a single piece casting, but it's like I think we need to get probably the Texas factory and the Berlin factory going.
Yeah.
And like we need like we do have an issue of like it's hard to change the wheels on the bus when it's going 80 miles an hour down the highway.
Yeah.
So you know, Model 3 is like most of our, or was most of our volume. Model Y will exceed Model 3. But it's just we just need basically an opportunity to kind of redo the factory without blowing up the cash flow of the company.
Right. Yeah. I mean, I understand you've got a lot of stuff in play, so we're looking forward to seeing what's going to happen in Berlin. That's when I'm really interested in, because, quite frankly, you're a lot closer to, you're a lot closer to the casting companies, and Germany has fabulous toolmakers. So I'm expecting to see lots of good stuff out of that. Are you going to have or maybe you don't want to talk about that, but are you going to have 3 castings then, or just 2?
Well, effectively, there'll be a rear casting, a front casting, and then the center will be a structural pack.
Yeah. So
structural pack is also, this is an important thing that I've been wanting to do since the beginning of the company. But it was always tough to kind of like, because it's a coupled problem. So like, and when you're in sort of high-speed R&D, you often want to decouple the problems, because you try to solve electrical issues in the battery, and you try to solve structural issues. And if you bring them together, then it's hard. You're putting the whole company at risk, basically.
Yeah.
But now, since we have Model 3, Model Y in production, and we have a new factory that's getting built, this is our opportunity to say, okay, now we're going to do a coupled problem where we're going to combine the battery pack and the basically body chassis, the primary structure, the primary structure, and we're going to transfer shear through the cans of the cells, and just do shear transfer, which gives you a super stiff, great moment of inertia. It's like a common. They do this with carbon fiber, and composite sandwich, like having aluminum honeycomb with upper lower carbon face sheets, and you get incredible shear transfer, and great moment of inertia. You get a real stiff big plate. And so getting dual use of the cells, and so the cells become structure. And that's like what the point I was trying to make at the battery drape presentation. But I think a lot of people didn't quite understand why that's such an important thing. The cells today in every car are carried like a sack of potatoes. Exactly. They actually have negative structural value, because not only they don't serve to aid in the structure of the car, and they have to be isolated from the rest, from the rest of the car. So it's isolated from, vibration and shock loads and that kind of thing. So then you've got to put mass into isolating the cells, because otherwise they'll bang against the side of the battery casing, and that's not good.
Yeah.
But by essentially bonding the cells in there, and where the bonding foam serves as both an adhesive and a fire retardant.
Yeah.
You basically get 2 birds with 1 stone.
Exactly. Yeah.
Yeah.
So multifunctional designs is something I really try and get the companies that I work with, I try and get them to do that. And we got a ton of people right after your battery show saying, oh, you can't do this, you can't do that. So we made one up, or made wood blocks and whatnot, and said, this is what's going to be. And then I talked a little bit about, what the effect is and the loading and transfer of loading and how much safer and stronger this is going to be on and on. It's the highest rated, I think it's the highest rated show we've ever put out. I'm just explaining, why this is such a good idea, because you got people, designing cars all over the planet,
Sure.
and they're telling me why it's not a good idea, and I'm saying, tell me again. I mean, really?
Yeah.
You're an engineer. This is the kind of stuff that really needs to have happen.
Yeah, I think it'd be helpful to show and tell, because if you say shear transfer, using a steel cancer, shear transfer between the upper and lower face sheets, what does that actually mean? Let's show you. This is what happens if you've got just a little floppy sheet, or you just have a limited number of stringers for shear transfer. You can see it's quite bendy. But as soon as you have a whole bunch of cans or honeycomb or anything like that, and you bond an upper lower face sheet, it gets crazy stiff. You can't bend. You can just put them together, and one thing's floppy and the other thing's stiff as hell. And that's really what you want. And then this will also give the torsional rigidity will be much better. And so if you're trying to improve the ride and feel of the car, you say what's the frequency of this car? Is it like a sort of real bendy spring, or is it tight? And that feeling of is this car tight? Really, if people don't understand why does this car feel better than the other car, it's because you've got your natural frequency is high and you've got good torsional rigidity. And then another factor is what is your polar moment of inertia? So basically, to what degree is the mass grouped towards the center as opposed to spread out towards the outside? And you can see this with an ice skater, where if the ice skater holds arms out, you rotate slowly, brings arms in, rotate fast.
Right.
That's what's meant by polar moment of inertia.
Exactly.
So it's can you rotate this car fast? You can if you bring the mass to the center.
Right. And quite frankly, we've had lots of people discussing, the pros and cons here. But to me, you were saying, well, we got 2 for 1, but you really got 3 for 1.
Yeah. Because
now you've got body stiffness that's gone up and all the other stuff that's gone along with it.
Right.
And then on top of that, you've got, when people say, well, what's it like to drive the car? Because again, we've stopped in lots of different places. And I tell them, if you get a 7 Series BMW and drive that, that's what you're basically getting. It's the same sort of suspension feel as that, and you don't have to. You're not muscling anything around. Everything is tight and perfect, and tight's a good. And then when you go to those 3, let's say 3 structural members, you put a body on top of that, it's going to be a perfect build. And as a guy who had to work in body shops, and as a guy who used to make molds and dies and whatnot, it's really difficult to take a whole bunch of pieces and glue them together, and there's nothing, right?
Yeah.
I'm just using fixtures, and then some
you're going to have
purchasing
tolerance stack up. That's the issue.
Yeah.
Is if you've got a whole bunch of separate parts, and each of them has got a given tolerance, even if that tolerance is tight, and it could be 0.2 millimeter tolerance, but you've got 50 parts. Okay, now
you multiply them together.
And
you can't win.
Exactly, and you're going to also have just variance between cars.
Yeah.
So that's for sure one of the reasons why it's best to just combine the parts and not have separate parts, and then also just go for extreme levels of precision. Mm-hmm. One of the examples we use at Tesla is Lego. So Lego is super precise because it's a press fit. I think they're precise down to about a 1/4 millimeter or less. Yeah. Basically about 10 thou.
And each one is exactly the same.
Yeah, it's got to be. And if Lego is too press is too soft or too hard. If it's too soft, the press fit won't work. If it's too hard, you can't get it on.
Right.
But they can make something that is a tiny fraction of a millimeter accurate, and it's a low cost toy.
Right.
Buy $20 for a Lego set, and so if Lego can be that precise, then so can a car.
Exactly. Yeah. Actually, I got to tell you, I applaud BMW for putting out the i3, but ugly. But the thing that we got from it was that carbon fiber body was absolutely perfect. And when if you had the stiffness of the castings down below, and you take a carbon fiber basically structure and put it over the top, absolutely every door is always going to be perfect. You won't have to have fixtures, you won't have to have anything, it just goes boom, done. That's ultimately what I think a perfect build is probably going to go for. But most people don't want to do it because they're talking about, oh, carbon fiber is so expensive. No, it's not. It's not really that expensive. And at the end of the day, you have to take it and look at it, a total accounted cost.
Yeah.
How much does it cost to basically, where's all the tooling and whatnot? How about all the scrap that you get on and on and on?
Yeah, I mean, there are some other issues with carbon fiber, which is that carbon fiber with resin has a coefficient of thermal expansion which is basically 0. And if you have parts that are, say, aluminum or steel, that's aluminum's got quite a high CTE. Stainless has, it's like about halfway. Yeah. It's like. So then, if you have like a hot versus a cold environment, like you can't have your doors jam.
Yeah,
so
correct.
Having, matching CTE is pretty important for things like a door frame. So that's, if we're using, say, steel, we probably need to stay with a steel door because otherwise we're going to get like CTE issues.
Yeah, but at the end of the day, we found out the tricks that BMW used. So they've got cross